Hello, I'm Dittoma, and this is stuff that I can't seem to think of at the moment because my brain is filled with stupid things. Hello! Once again, this is Dittoma, and it is my job to explain centripetal force. But what is centripetal force? Imagine you have a ball on a string. You spin the ball in a circle, feeling the ball tugging away from you. What if you were to let go of that ball? It wouldn't just keep on spinning in a circle, would it? It would fly off. In fact, it would always fly in the direction the tangent at the point points. Why? This is because the tangent represents the direction the ball is currently going in until it is changed. That's right, changed. When you spin a ball, you are constantly changing its direction. You can tell because F equals ma. An object, in this case your hand, experiences force if another object is accelerating and pulling on you. Hold on, you say. Accelerating? But it's spinning at the same speed, right? Right, but acceleration is a vector and depends on direction as well. The speed of the object is the same, but its direction constantly changes from, say, north to east to south to west and so on and so on. So, this means that the object is accelerating, and due to Newton's first law of motion, an object remains at rest or at a constant motion unless acted upon by an external force. In other words, acceleration can only happen if there is another force. But from where? From you. Well, more specifically, the tension in the string you're holding onto. When you spin an object, its inertia makes it want to go one way, but due to Newton's third law, the string is pulling the ball back towards the center of the circle. This is known as centripetal force. It keeps pulling the ball back in and in, creating a circle. This is also seen in satellites, how they are pulled in by the Earth's gravity. Side note, centripetal force isn't a special kind of force, it's just the name we give that type of force. It's still just a normal force acting on an object, but because it's creating a circle, we just name it something. The centripetal force also depends on the object's mass, speed, and the radius the object's creating. An object needs more force if it has a greater mass, because greater mass means greater inertia, meaning the object resists the centripetal force more, meaning you need more force to pull it in. If the object's moving faster, then accelerating it in another direction requires even more force. As for the resultant force to be the same, whilst force A is larger, then you would have to make force B larger as well. Finally, if the object is closer to the center of the circle, the centripetal force will be greater, as an object will be accelerating faster when it's nearer the center. Think of a car turning around a large roundabout at 30 miles per hour. When you're driving, you don't have to turn a lot. In other words, the car is not accelerating a lot. However, with one of the very tiny painted ones, when you turn at 30 miles per hour, you get thrown to the side due to the fact that the object is turning a lot, meaning it's accelerating a lot. And as explained before, if acceleration is greater, then the force applied is larger. Therefore, the centripetal force is larger. Right, I think I'm done. I just need to